Did Archimedes really build the first directed energy weapon in history? We begin in the 3rd century BCE, in the city of Syracuse, on the island of Sicily. At the heart of this Greek stronghold stood a man whose intellect would echo through millennia, Archimedes, mathematician, engineer, physicist. But among the most controversial is a tale that borders on science fiction. The so-called burning mirrors. The goal set them ablaze from a distance. With pure solar power, inventor of the first known energy weapon in human history, the Roman navy launches an aggressive siege on Syracuse, trying to break through its fortified walls. According to some reports, the Romans were repeatedly frustrated by bizarre and devastating inventions credited to Archimedes. Cranes that lifted ships out of the water, rolling stones that crushed battalions, and yes, sudden unexplained bursts of fire that engulfed wooden vessels. Archimedes is credited with countless achievements: the principle of buoyancy, the lever, the screw pump. According to ancient Roman accounts, particularly from Lucian and later Anthemius of Tralles, Archimedes devised a system of highly polished bronze or copper shields, arranged in a parabolic formation to reflect and concentrate sunlight onto Roman ships besieging Syracuse. In fact, the earliest references to the death ray concept appear hundreds of years later, well into the Roman Empire. Powerful beam. Much like a magnifying glass can ignite dry paper. Theoretically, the combined solar energy could reach ignition temperatures exceeding 300 degrees Celsius. Enough to catch a wooden ship's sail on fire. It sounds unbelievable. And yet the legend persisted. How? Let's rewind to the Second Punic War. 214 BCE, skeptics and believers have tried to answer one burning question. But here's the catch. These stories don't appear in contemporary Greek accounts of the siege. So what's real? What's myth? To find the answer, we must explore both ancient science and modern reconstructions. Greek scholars were already familiar with the basic laws of optics, including Euclid's theories, which predated Archimedes, the concept of concentrated solar heat. Archimedes was a master of geometry and optics. He had access to materials like polished bronze and the understanding of reflection angles necessary to manipulate light. The theory was simple. Multiple mirrors angled just right could concentrate sunlight into a single, but theory is not proof. Over the centuries, could Archimedes really do it? Modern experiments. Mythbusters versus MIT. One of the most well-known attempts to test the idea came from the show Mythbusters. In 2004, they tried to recreate the setup using 300 polished mirrors held by soldiers, aimed at a small-scale model of a Roman ship. The result? Mild scorching, no fire. Conclusion: myth busted. They used 127 one-foot square mirror tiles and aimed them at a mock wooden boat 100 feet away. After steady concentration, the boat's surface began to smolder and catch flame, and no movement from the target. Conditions unlikely in real naval warfare. The story doesn't end there. In 2005, a group of MIT students, led by Professor David Wallace, re-attempted the experiment with greater precision. It worked. Barely, but it worked. Wallace stated that while the method could theoretically ignite a stationary ship, it would require calm weather. Perfect coordination. Still, the demonstration suggested one critical point: the ancient death ray was technologically possible, even if militarily impractical. Was it ever meant to be a weapon? One alternative theory suggests that the so-called death ray might not have been intended for direct combustion at all, but rather a psychological warfare. Imagine a line of bronze shields catching the sun and flashing blinding light across the harbor. From the Roman perspective, it could look like magic. Confusion, panic, and superstition would do the rest. Or perhaps the story was born after the fact. A blend of admiration, fear, and mythologizing a genius whose machines already bordered on unbelievable. The reflective material Archimedes didn't have glass mirrors as we know them today. In his era, highly polished bronze or copper would have been the go-to materials for reflection. But polished metal isn't as efficient as modern mirrors. Its reflectivity is around 60 to 70%, compared to 90% plus for modern silvered glass. To compensate for that loss, Archimedes would have needed either. That's geometrically complex, especially on a moving battlefield. With wind, sea, and shifting ships, a large number of small mirrors, or concave mirrors curved inward like satellite dishes, which naturally focus light to a single point. This is more elegant, but also harder to manufacture in the ancient world. A few massive concave reflectors, precisely shaped, a few degrees off, and the energy disperses. No fire, no weapon. Creating that many polished surfaces in consistent curvature by hand would have required incredible craftsmanship, but not impossibly so. Ancient Greek metalworkers were capable of crafting curved armor, precision instruments, and ceremonial shields with surprising accuracy. The geometry of fire? Assuming polished bronze shields, the next challenge is focusing the reflected sunlight onto a single point and keeping it there. For flat mirrors, this means adjusting every angle manually so that beams converge on the same target. The other option? But fresh timber contains moisture, and ships were often coated in pitch or resin. Flammable, but also protective. Some scholars speculate that Archimedes may have used a combination, flat shields for general deflection and a central parabolic mirror for ignition. But here's the twist. But that assumes calm winds and stationary targets, rare in real warfare. The more mirrors you use, the more alignment becomes critical. Target material, let's assume Archimedes could aim sunlight precisely at a Roman ship. Would it burn? Ancient Roman vessels were primarily constructed of pine, oak, and cypress wood, all of which ignite at roughly 300–400 degrees Celsius. Add to that moving sails, ocean humidity, smoke, and shields, and suddenly the ignition scenario becomes much harder. Mitt's tests showed that the sailcloth, rather than the hull, was the most likely ignition point. Timing and sun position solar power depends entirely on light intensity and angle. That means it only works in direct sunlight. The mirrors must be aimed with minute precision. It's ineffective in cloudy or low-angle sun conditions. Would Archimedes coordinate dozens or hundreds of shield bearers? It's precisely aligned. In mid-battle, just as the sun hit its peak. Highly unlikely. Unless the weapon wasn't designed for open combat, but for siege defense. From high city walls, targeting stationary or slow ships trying to breach the port. This scenario adds tactical logic to the legend, a tool, not a weapon. Modern historians like Dr. Cesare R. Rossi argue that Archimedes' mirrors may have been used not to ignite ships, but as a communication device or blinding deterrent. A sudden flash of intense light focused into the eyes of approaching sailors or soldiers could cause panic, blindness, or confusion. In the chaos of war, this alone might turn the tide. After all, fear is a powerful force multiplier. The psychology of legends. By the time Roman writers told Archimedes' story, centuries had passed. The legend had grown in the retelling. What may have started as a sunlight-based deterrent, or even a misunderstood optical demonstration, came, over generations. A myth of a genius who could set fire to ships with the sun. Did Archimedes himself ever call it a weapon? We don't know. None of his writings survive on the subject. All we have are secondhand stories, often written centuries later by authors with political or philosophical agendas. And yet, the very fact that modern science has shown such a device is theoretically possible. Even in 200 BCE, suggests that the legend of the death ray may have a seed of truth. The story of Archimedes' burning mirrors is more than just an ancient footnote. Whether fact, fiction, or some blend of both, it has endured for over 2,000 years, resurfacing in science, warfare, and popular culture in unexpected ways. But why? Because the idea touches something primal, gives harnessing the sun to destroy, and even aircraft, gives controlling nature itself, with precision, gives a weapon without fuel, without fire, without noise, just light, geometry, and brilliance. Today, modern militaries across the world are actively developing directed energy weapons, high-powered lasers, and microwave systems designed to destroy missiles. Drones, these systems, use concentrated energy, not explosives or silent, invisible. An instant require immense precision and computing power. Sounds familiar? In many ways, Archimedes' alleged invention mirrors these 21st century efforts, using concentrated beams to damage or destroy distant targets. The US Navy, for example, has already deployed ship-mounted laser cannons, capable of burning through metal at a distance, primarily used for missile defense. One could argue that if Archimedes had modern optics and electricity, he'd have been the first laser engineer in history. The Renaissance rebirth. During the Renaissance, as classical texts resurfaced across Europe, interest in Archimedes surged. Scholars like Leonardo da Vinci and Galileo studied his surviving works, praising his geometric mind. But it was the death ray myth that captured imagination. Military engineers theorized solar weapons. Even Isaac Newton referenced the power of optics in weaponized form. Artists painted scenes of Archimedes with flaming mirrors. Archimedes' legend inspired not just mathematics, but fear, fascination, and ambition. Pop culture and sci-fi, the idea of a solar weapon lives on today. In movies like James Bond, Die Another Day, where a space-based solar reflector becomes a satellite death ray. In games like Civilization, where Archimedes' death ray is a literal wonder of the world in science fiction lore. From steampunk war machines to solar-powered orbital lasers, the story blends mythology, science, and imagination. Exactly the kind of hybrid narrative that sticks in cultural memory. It's more than a weapon. Perhaps the most powerful part of this legend isn't whether it worked, but what it represents. A moment in time when science, war, and creativity converged. A glimpse of what humanity could do, even with primitive tools, when ingenuity was pushed to its limit. Archimedes, even in death, became a symbol of the mind's power over matter. He wasn't a soldier. He didn't lead armies. And yet the greatest empire of its age feared him. His inventions, whether real or exaggerated, shaped the psychological battlefield. Even after the fall of Syracuse, even after he was killed allegedly by a Roman soldier ignoring orders to spare him, his name echoed in the minds of scholars, tacticians, and visionaries. The final question? Did it work? The truth is, we may never know. No definitive archaeological evidence survives. No original blueprints. Just scattered references across centuries, wrapped in legend and intrigue. But in a way, that's what makes it powerful. Because if Archimedes' solar weapon didn't exist, it's a testament to how captivating the idea of it is. And if it did, even briefly, even imperfectly, it redefines what we thought possible from ancient minds. So when we ask, did Archimedes really build a death ray? We're not just questioning the past, we're asking how many forgotten technologies, how many lost ideas? How many buried breakthroughs still lie between the lines of history, waiting to be rediscovered?